how it works. Each one of them is going to pick a color, and this color is a coaster that I always tell my students, please don't use it as a coaster. This coaster is just going to represent the color, so I'm going to ask you to distribute these ones. Each color has 4 circular coasters. These circular coasters, 3 of them have a skull. I mean, one of them has a skull, and the other 3 have roses. This game is also called Skull and Roses. So let me just check. So you pick this one, and if you have seen, I have already used this game a lot. So there is this one over here. Oh, you have the Viking skull. So that officially, you can officially Viking skull people. All right, so here's how it goes. Everybody is you're going to grab your coasters. And first of all, we're going to do the setup phase. In the setup phase, the only thing that you're going to do is you're going to choose one of these coasters and you're going to put it down here. So it's your choice. Now, I'm going to, for the sake of the explanation, let's say that all of you are going to put roses. Yeah. All right? So let's say that Earl is going to start, well, you have to put it down. Yeah, I forgot the details. All right, so now the thing that you are going to do is you have 2 options in this round. You can either choose to place one coaster down, or you can say a number. For the sake of the explanation, let's say that you choose to put a coaster down. So put a coaster.
Another one?
Just one.
Okay, all right.
Now it's your turn. You can choose to put a coaster down or say a number. For the sake of the argument, let's say that you choose to put a coaster down. Let's do the same thing here. Suppose that you choose to put a coaster down. You 2 and you 2. Then we go back to Earl, and Earl decides now to call a number. The number that he's going to say is the number of coasters that he can reveal without revealing a skull. So he has the information of his coasters, but he doesn't have the information of the rest of you. So he can say 1, 2, 3, 4, 5, to whatever he decides to. Now, we're going to continue. Then once you say a number, let's say that you say the number, what will be a safe number? 1, 2, 2. All right, so he says 2. Now in your turn, you can pass or you can raise the number.
So it's the skulls that are in all of the hands.
Okay, so I'm going to tell you what's going to happen. So once everybody passes, we're going to end up with a number. The first thing that you're going to do is you're going to reveal your coasters first. If there is a skull there, you lose. If there is not a skull there, then you start picking people to reveal the coaster that is on the top. So you say, for example, I want Pat to reveal his, and then you will reveal your first coaster, and then he can choose you again. So let's say, would you like to go higher than 2?
We'll go 3.
3. Let's say there, right? Well, I mean, 10 coasters.
So can we go back? So that when he picked 2,
yes,
he was stating
he's
that he thought
claiming
that there's 2 skulls
he can
in total
no,
among.
he can reveal 2 coasters without encountering a skull.
In my deck.
No,
Or anyone's deck.
Well, you start with yours, and then you start picking from other ones. So she's saying 3. Well, this is just a practice round. What do you think?
Can I ask, when you do reveal them, are you revealing them from your own first?
Yes.
Or just from the top of
No,
your
no, all of yours.
All of yours.
So if you put, I mean, you can put a skull over there and you can start increasing the bid, but if you got stuck with the highest bid, then you're automatically going to lose because you're going to reveal yours first.
Oh.
All right, so what do you think? 3.
You said 3?
Yes.
So I'll say 4.
4.
I'll pass.
You will pass.
Right? That's the option.
Yeah, you will pass.
I'll pass.
I'll pass.
You will pass. 4. What do you think? You will pass?
I'll pass.
I'll pass.
You're
All right.
passing? Yeah.
All right, so reveal yours first.
Okay.
So 1, 2. It was kind of a little, look, you only have to reveal 2 more. and you
Only
will
2
win.
more.
Yeah.
Yeah,
All right, just look at them. Do a little bit of the man. Why did you?
So it's got to go a full cycle of passes. and then
Yes.
that's who decides who reveals
until-
it.
if
So
it
whoever was
goes-
the last one
yeah.
to raise
Yeah.
is the one who starts
Yeah.
showing theirs. Gotcha.
Okay.
So 4 out of 10, right?
And are like we
And now
not
you got-
are we not supposed to know the order of ours?
No, yes, you
Like-
are.
You picked
You
whether
have
you
your
put
own,
a
you
rose
pick-
or a
you-
No, no,
skull.
but like when I have my stack here.
Those are not in play right now.
Oh, okay.
Okay,
just
so I
decide.
have, okay, so can I pick one of his?
You have to pick the top. So you
Okay.
can just point at him and he has. You're going to get Viking's call.
Ah, okay.
One more.
Just one more. Okay. Okay, I'll try.
Are you sure?
Ah, yes,
so,
I
so
win.
supposedly the thing that you will do is you will flip that.
Okay.
If you flip again, you will win the game.
Okay, so you gotta
Oh.
win.
If for some reason you got the bad one and you reveal a skull, you lose one coaster.
So do we take back?
So take back everything, and now you're going to play on your own one round, and we're running out of time, so because of my technical issues. So there you go. Play one round. Let's say since you won, let's just flip it back. So you start. So everybody you choose a coaster. Could be the skull, could be roses. Just put one on your squares coaster. Put a coaster down. Could be anything. You decide.
Just one?
All right, just one. All right. Now you have the option to say a number. You can say a number right now if you want to, or you can put a coaster. What do you think?
I'll say one.
You will say one. Let's say bet, huh? What do you think? One coaster. You can reveal 2 coasters out of 5.
Yeah, I'll go 2.
2. All right, good. 3 coasters out of 5.
Can I pass?
You can certainly pass. Pass.
3 coasters.
3 coasters. 3.
I pass.
Pass.
4. Oh, well, I think that you already passed.
That's
so
right.
you don't get- Okay, 3.
Oh, I
So
passed. That's okay.
4 coasters.
4 coasters. All right. So reveal them. So you reveal yours first.
And
And so everybody bought one, right?
Ah!
So the thing that you will have to do, we're not going to continue the game because I have a talk to give. But if we continue the game, you will lose one coaster and you will continue on. So the other thing is you actually drop it blank. So you really the people in the table don't know what
If
coaster
he
you
got, if
lose.
he describes
So
a
the-
To lose
skull
one
or
of
a
these 4
rose.
coasters.
Yeah, so now you have less information that you can manage. But you can see how conditional probability and how just even just talking about fractions in here, when I am saying 2 out of 5, it kind of gives you kind of an idea of when you can go, and it has like the best part of poker without being poker, that is kind of like reading people. If somebody say 2, maybe it means that their particular kind of like the particular setup was for roses, but who knows. All right, well, thank you very much to our volunteers. I'm sorry that I couldn't not present you the other thing that I used, but
You can
was
talk
not
about it
meant to
briefly
be.
if you want.
So this is one of the games that is called Skull. I hope that you like it. I hope that the people of the crowd didn't kind of get bored by this. But my students seem to like it a lot. Some of them find it incredibly stressful. I took this one to one of an IBL workshop, and all the math professors loved it. So I thought that it was a good idea to show you this one. Now, I will talk about a lot about board games. Don't think that I'm trying to sell you board games. I don't get paid by board game companies to sell you board games. But what I'm going to sell you the idea of why board games can be helpful for your classroom in what particular ways, or how the board games are helpful for me. So I was like, I don't want to sell board games, so I didn't include the MSRP for this guy, but I think that is around $25. And I think that your kids can have a lot of fun. one of the things with playing board games in your classroom is you do have to invest some money because unless you have a very small class, you need a lot of board games. So this one kind of is a good option. All right, so let me just go back to my presentation here. And let me just first tell you a little bit about the buzzword. The buzzword is gamification. This is big in corporate America. They are trying to do everything with gamification. They try also, I don't know if you have heard about this, but they have tried to do this too in education. So there are two parts of gamification. My talk is not about gamification, but I can see how it can be related to gamification. The first part of gamification is first of all, nobody has like a formal definition, but some people, the way that started is adapting things on particular video games into certain activities in order to encourage people to do things. So there are two things that I called, there are two types of gamification that I like to separate. One is artificial gamification, and the other one I would like to call a more natural gamification. So let me just start with the artificial gamification. But I mean, let's say the term artificial seems to be like a little bit derogative, but it is not. It's actually, in some cases, pretty effective. Actually, let me just show you. In my work back here, I do have one of my gamification utensils for my college students. And the word is recent, but actually this type of gamification has happened since the beginning of stickers, I guess, I'm teaching. So I was teaching my Cal 3 class, and we do kind of like daily writings, so they just have to do a particular problem and turn it in the next class. So one of my students said, you know what, Dr. Taylor gave us stickers every time that we do our handling assignments. I was like, that's so high school. Why you're doing that? I mean, not to offend. I mean, it's cool, but exactly. So I was like, stickers, and they say yes. If they get a good grade, people get stickers, and they put it everywhere in the workbook. And when I go, so I asked the entire class, will be significantly improve your experience in the class? And everybody said yes. So the next day, I am stealing stickers from my daughter, like a spring stickers. Anyways, so that's artificial gamification that is kind of like, it can be good in certain scenarios, but also can be bad. For example, the incentivating without any kind of without a purpose could lead into something kind of disastrous or that it defeats the purpose. For example, I listened to a story that, I don't know if it's true, but in India they were trying to get rid of snakes. So this particular region was they were incentivizing people to kill snakes, and if they kill snakes, they get some money. They got some money. So after a few months, what happened? People were raising snakes in order to kill them, in order to get the money. So you have to be very careful of when you incentivize what, because otherwise it could actually defeat the purpose. So there are a lot of, I put this slide because this is very, very artificial gamification, right? Like the Endomondo app that you run and it gives you points and you're like, ooh. Or the likes. You can get likes, and more likes you get, the better it is. Why? Just because. But I actually found one example of natural gamification. I'm going to show it to you right now. This is an example of natural gamification. This one is incentivizing you to do the act for the fun of doing it. So do you see what it is? It's like, throwing the trash is kind of like, I mean, throwing things in trash is kind of natural, and some people can find it boring. But in this case, we have a natural way that you can make throwing the trash a little bit more exciting. I mean, and it's a little bit more inviting. So the fact is, you are not artificially making a game out of these. I mean, what you may say that it's artificially putting a hoop over there, it's something artificial, but you are naturally doing the action, and you are getting some kind of fun of doing the action. Well, this is going to be related to what I'm going to talk about, and since my technical problems, I'm going to have to go a little bit fast. So let me just give you. So I'm a board game enthusiast. So I sometimes was listening to some board game podcasts, and they came to something called, some website designer, they were talking about something called the user experience, that they like to call UX. According to my friend Google, the overall user experience, according to Google, says that the overall experience of a person using a product such as a website or computer application, especially in terms of how easy or pleasing it is to use. Now, if you have kids, I'm going to give you an example of something that I think that a lot of you will agree that this doesn't give you a positive user experience. That is the YMCA registration for summer camps.
It is not that.
Oh, it's horrible. It gives me absolute negative user experience. I find it clunky. I find it kind of difficult. Sometimes you have to select the branch first. Sometimes you have to select the program first. Then they don't tell you if it's open or not. Well, for me, that's negative user experience. But so what I'm going to tell you what I'm going for is that our mathematics classes are constantly competing for our students and their interest. And I don't. Could it be that the lack of interest of some of our students in mathematics is because of the user experience in classes? Could it be that these students is just that they are enjoying the user experience? For certain reasons, because they are not interested, because, oh man, who cares? So, let me continue with this thing. It is often overlooked, and it's kind of like sad that sometimes our user interface for our classes is a blackboard and us kind of writing down stuff. So, in particular, if you are, and if you are in a very kind of like intense class, sometimes it's very barren the way that you are going to present the stuff. In particular, in graph theory, it's kind of like that. These are all the definitions that I have in my old notes. Before getting to the first theorem on graph theory, they had to go to all these definitions, and then you get to the first theorem of graph theory. So the thing that happens is they get incredibly, that first week is like kind of, when this is going to end, and then to get to a theorem that may not relate to what they are interested. So that was the problem there. I was going to teach a graph theory class, but I was like figuring out how I'm going to avoid going to all these formal definitions. Now, let me just give you a background. This is a class, a 400 level college class. And it's a proof-based class. So those are the things that for college kids, they're like, proofs, what? No. So, and it can be taken by everybody. So I wanted something that can be taken by everybody, engineering students, math majors, but that they can, at the end, they end up learning and having a high level graph theory class. So let me just tell you, I taught this class 2 times. Let me just tell you how my class were configured. Now, great advantage, they were small classes because it's a higher level class. So what it means in particular is that the students are not going to be that many. For a higher level class, this is a good, it's like a good size class, actually. We were expecting to have way less. So the majors were renewable engineering this is in fall of 2016. mechanical engineering, ceramic engineering, you have 2 math majors and 1 chemistry major. Now the funny part is that in last spring, we have more or less the same renewable energy engineering, a lot of engineering students, 1 physics and 1 history class. And we have 3 math majors. So the history class was kind of interesting to have a history major in that particular class. So anyways, I want to tell you how it goes. Well, the other thing that was kind of interesting is that we have a full first year student, one of my engineering students was a first year, and another one, the history major, it has a junior, had a sophomore status, but he was a first year student too. Now, all of these ones require, since it's a 400 level, I had to approve them. So the lower year students tend to be somebody that I can trust that they can take this class. So that keep that in mind. So we have 9 seniors, 3 juniors, 8 seniors, 2 juniors, 2 sophomores, and 1 first year. So here's the idea. So I was going to teach this class, and I was like, well, how I can make this thing less barren? So I said, well, why I don't use board games? So the idea, I had the idea, I didn't know how to word it until one of my students, we were in the math suite, and one of my students, one of my calculus 2 students asked one of my graph theory students, how is the games class going? And I assume that now you're really good at games. And she said, no, I'm not really good at games. Now I know why I lose all the time. So I know the reason why I lose all the time. So instead of using mathematics to get better at playing board games, the idea of this class is to use board games to get better at understanding mathematics. And that's basically, in a nutshell, what I'm trying to sell you. So here's my solution. My instructional method, I went to what is called inquiry-based learning. That basically what I do is I have some notes, I give them the notes, and they start working on the problems. I create a set of notes based on these 2 particular books, and then my newfound expertise on PowerPoint allowed me to do that, and here's kind of like my notes over here. So, let me tell you the class structure. Once a week, the students play on board games. This was in the 2016. They lent us one of those psychology observation rooms, so it was a little bit creepy. They were playing a board game. Yeah, they have all these like classes that at the end, who knows where, who knows who was seeing. No, it's observing those ones. So we were observing them. All right. Anyways, so they were playing board games. I'm going to tell you about the board games a little bit, if I have time. So here, playing once a week, they play a board game. And that's the thing, that's the class, board games. In 3 of the remaining classes, the students work in teams solving the problems from the notes. So for example, here they're solving. Now this is during the spring. So they are doing a theorem over here, they have the proof, they're thinking about it in groups. But this guy has his notes. Here's another one, I just separate them in groups, and then they start thinking about the problem, and thinking about the problem. Here there is a graph, I'm thinking about the problem too over here. So let me tell you about the games, and I'm going to explain why I choose these games and why I want to, maybe let me back up a little bit. The idea that I want is to make sure that the students get the concept from a different media, right? From a different way, from a different road. And the road is going to be the board games. And that will ease them off into those definitions that I still have to cover anyways. So let me just tell you the first one. The first one is Ticket to Ride. I don't know, it's super famous. I don't know if you have seen it before. It is 2 to 5, playing time 30 to 60 minutes, so it fits very well in a 1-hour class, ages A and up. The designers are Alan R. Moon, and publisher is the Days of Wonder. Let me just tell you what is the game all about. Ticket to Ride is a network building game. The board is a map of the United States. And let me check if this trick. Oh, it does work. All right, so this is the board is the map of the United States. So notice that the thing that we have here is the cities are represented by dots. I never told you what graph theory is. I'm going to tell you what is a graph later on. And then each one of the cities is connected by these blocks. And these blocks have different colors, and we will see why that's important. So cities are connected by routes with different lengths. So the thing that you have is So in your hand, you're going to have cards of different colors. Each one of the colors are kind of like corresponding to the colors on the map that I showed you before. So the thing that you're doing is you're collecting these cards of different colors, and we have the amount of cards that you need for claiming a route. You lay down those cards, and then you put your trains in the corresponding route. At the end of the game, if you connect the cities that you have in your tickets, you get this amount of points. In a nutshell, that is what Tickets Right is. It's important for me to tell you how to play these games, because then you will see how I can relate these concepts to graph theory. Elfen Roads. Elfen Roads is also, now this one is 2 to 6, playing time is 45 to 90 minutes, each 30 up. The designer is Alara Harmoon, that is the same designer as before. Have the theory that this guy knew graph theory and is not telling anybody about it. The publisher is Rio Grande Games. And the idea is Elfen Roads is a route building game. So it's again the same thing. Now, the map, you will see that it's very similar, except that in this map, it's as far as I can go. This map, you have cities, and they are like fantasy cities, and you have roads connecting them, right? More or less the same thing, but now here you don't have blocks, you just have the roads. So the idea is the following. The thing that you're going to have is your objective is to visit as many cities as possible. All cities are connected by roads, and every player receives transportation tokens. So we're going to see later on. Every player is going to have a booth that's there, and each one of the cities, you're going to put a cube of your colors. Once you get to a city, you're going to pick up the cube, and that means that you visit that city. So the one that has the most cubes means that is the one that visits the most cities, and that's the one that wins. Now, how do you move from city to city? The thing that you have is the players are going to alternate putting these different transportation tokens. So you are going to say, in this turn, this road can only be traveled by dragon, right? And now the thing, since it's in a forest, you need 2 dragon cards to actually move it. So the thing that you have in your hand is these different fantasy like cards and animals or those kind of things. And then the thing that you have to do is you have to pay, and then you start doing your route. So this is kind of like a route building game in the sense that you're going around and trying to visit as many cities as possible. The next one is called Scotland Yard / New York Chase. Now this one is one that is called one versus many. The players are 3 to 6, playing time 45 minutes, each thing and up, and 15 minutes left. Designer are all of those guys. Is the publishers Robin Parker and Milton Bradley. If you are old as I, you may have played this in the old Milton Bradley kind of edition. Oh, one player is Mr. X, while the rest play as detective trying to catch Mr. X. Notice that it's going to be the same idea. You're going to have locations, and these locations are going to be denoted by numbers, and some locations, some pairs of locations are joined by different kind of lines, different color lines. They are representing transportation. So both Mr. X and the detectives are using transportation in order to get away from each other. I mean, to the detectives to track Mr. X and Mr. X to try to get away. So the detectives have a pool of these tokens, taxis, buses, and subways. And the thing that you do is you pay a taxi, you go from one, you go from one particular place to another place that is connected by a yellow line. But you go one by one. The bosses, the thing that it does is now you can go from one, and let me check a good one, this one over here. So you go to one particular blue station to another particular blue station. So another, for example, over here, you travel 2 spaces instead of 1. You cannot go whenever there is not a blue line, so you cannot go from here to here by a bus, but you can go from here to here, from here to here, from here to here, using a bus. And so on. And the underground uses the dotted lines, but now it goes faster. It goes like high. And the idea is the detectives start losing tickets, and then they have to trap Mr. X. There is other stuff that happen. Eventually, Mr. X reveals its location, and you have to trap it. But anyways. The other one is another famous one that's called Pandemic. Our players 2 to 4, 45 minutes, ages 8 and up, Matt Leacock, designer and publisher, Seaman Games. And this one is a cooperative game. Again, the same story. Notice that there is a trend over here, that the spaces are kind of like dots, and you have lines connecting these spaces, and the thing that you're trying to do is to eradicate viruses and diseases, and the player trying to prevent diseases from spreading while trying to find their cures. So the thing that you do is the particular players go to a particular location, and they can remove a cube, sometimes 2, and so on. But they have to move over here, and sometimes these things get overrun and block your way, and so on. So let me just tell you how this helps to understanding graph theory. Again, so notice that all of them have a particular topic, that is, the boards have dots and they have lines joining a dot. Now, when you come to, after they have played the game, and you come to the definition, a graph consists of a non-empty finite set of objects called vertices. Some people call them nodes, and that kind of gives them a hint, together with a possibly empty set on ordered pairs of distinct vertices called edges. If I give you this definition right now, you could be like, well, what's going on? What he's thinking about? But if I told you, look, these are just these cities, and edges are just the roads. So what I'm saying here is this map over here is what we call a graph. The vertex set, blah, blah, blah. So again, so the thing that it does is the board games, it's not that they are teaching the map, but this is the way to give kind of like a particular idea of what I'm trying to explain, or what objects we're going to use for the class. There is another concept that is called the degree of a vertex. And again, in my notes, I try to always stress, look, for example, what are the vertices on Ticket to Ride? What are the cities? What are the vertices on Elfenlands, the cities? What are the, and so on. So you kind of visualize what a graph is in your own game, in the game that you play. The degree of a vertex, being a graph G, is the number of edges incident to be. I have a definition of incident. Incident are just vertices that contain that particular vertex. The degree of B is denoted by degree of A above. Anyway, so these are just terminology, not more general. But now, if you say, look, the degree of a vertex is just the number of roads that are coming in or out, that are just converging to the particular city. So for example, this city has only one road, the degree is 1. Now this is important also because in this particular game, the degree becomes very important since you are trying to visit all the possible towns. This town is a very difficult town to visit. Why? Because it has only one road. So this town becomes a priority when you're thinking about, well, should I visit that town or should I maximize visiting other towns? And that's just because of the degree of this vertex. On the other hand, this city has 1, 2, 3, 4, 5, 6. So the degree of this vertex is 6. So that means that this is one that you can mostly visit no matter what. Now, remember that the visiting is restricted by the tokens. So for example, from here to here, you can only use dragons. So if you don't have dragons, these kind of situations become important because then you have to place tokens here of the cards that you have. But I'm not going to go too much into this. So this is from their final exam. You can also, there are concepts that are really related to the objective of this game. So a graph is said to be Hamiltonian. So a graph is said to be, a configuration like this is said to be Hamiltonian if you have a certain way that you can visit all the possible cities. So there is kind of like a natural kind of relation between this. Another thing is isomorphic graphs. So in one of the first activities, I said, well, take this map, and can you tell me just what is the underlying graph on this map? And my students, one group of my students, decided to put them in a circle and created this mess right here. Now, but what this is saying is basically they put all the cities over here, and they just connect with a line if they were connected with a road. So technically, you could play Ticket to Ride here, although it will be kind of a little bit more boring because it doesn't have any theme. But it tells you that these two configurations are the same. As networks, they are the same. Graph theory is used to study networks, and in particular, you can even do social networks and so on. Induced graphs. So for example, a graph is induced if you take the vertices, you take all the connections that join those vertices. So for example, in this case, I asked them to find the induced graph of these 5 and Boston, and that's what they got in one of their particular solutions. Tree and spanning tree. So when you take Ticket to Ride, your objective is to maximize the points. In other words, you want to connect as many cities as possible. So in this case, the students later on realized that having kind of circles like this is not very efficient because you are wasting connections to go from this place to this place. On the other hand, let's say, since that the black is maximizing all the possible connections, it's on the west coast, it's on the east coast a little bit, and it's in here in the area of Missouri and Oklahoma, and kind of can connect to different places very easily. And that's because trees are more efficient with connections. And by a tree, I mean a connected graph that doesn't have circles. So if you don't have circles, you can connect more. That's basically what it is. And you can see how the people that got that idea, when they start playing the game, they start to get better at the game, actually, although it was not the objective of the class, but that's the thing. Now, let me just tell you a little bit about my assignments. I did do homework assignments. They have 2 assignments. Students have 2 assignments, they have 2 assignments, writing assignments and game reflections. The writing assignments, I asked them to do 1 problem on the notes, 2 or more problems on the notes. Here's another one of my tricks. I do like this post-cognition kind of thing every time that you do an assignment to say, well, what did you learn on this section? And also I like to put the level of confidence so I can track how they're feeling with respect to the stuff that they are doing. The other one is the game analysis. That is basically a way to enforce that, okay, so although you're playing a game, you still are taking a graph theory class. So it's still laid down to mathematics. What in your game, what are the vertices? What were the nodes? The cities? What are the edges? I have to admit that after a little while, it became a little bit repetitive. Just to finish, let me just give you some feedback. This first feedback is for our first year engineering student. So this student is pretty bright, but she had absolutely no experience with proofs. So here's the first one. What did you learn in this section? I learned how to prove the first theorem in graph theory. I'm not sure if I proved the second one at all. I don't know, she was thinking about the second theorem of graph theory, but I don't think so because we didn't go to anything called the second theorem of graph theory. But I mean, she could have proved it. That's not true. I think that she was meaning about the second exercise of that. Now the next one is, I learned how to prove theorems. I was like, yes. And then comes the third one. I learned that I can begin to understand what I'm trying to prove, but I can't put it into words with some guidance. And that's completely normal for a first-year student trying to prove. What did you learn in this? And that's one of the objectives, at the end of the course, to be better at putting your mathematical ideas on words. I learned that I know how to do proofs somewhat more than before. So still kind of not that sure. So now let me just tell you the student evaluations, and I put the student evaluations that are kind of relevant. I didn't put negatives because all the negatives I can tell you right now, the game reflections are redundant, and we can use, can you put less on the exams and things like that? Well, I'm sorry, I don't call my exams, I call them celebrations of learning. Because we celebrate what we have learned, right? So I was teaching once.
Celebration.
But I buy them some treats. So I was thinking a long time ago, the first time I called them celebrations of learning, I bring my celebrations of learning and everyone like, hey, this is just an exam. I was, no. And then a guy delivering a pizza comes with a pizza. At the end of the exam, here comes this kid and said, thank you very much for the pizza. It really takes the edge out of my exam. And I said, no, celebration of learning. so it's kind of like, I mean, it's kind of like telling them, look, this is not, I mean, you are going to get the grade of this, that's the way it is, but I mean, there is a different way that you can do it. So what did you learn about the course? Well, and some of them, of course, the negatives is like, don't call them celebrations of learning, but they are exams. But they are celebrations of learning. Connecting board games to graph theory was very useful. All right, cool. I like the integration of board games to learn about graph theory. It was helpful to have the visual, and this is the thing that I like. That's why I put this one. It was helpful to have the visual, it is not
Of the game.
of the game. Like license 8 over here. When learning about the definition and the problems being worked on. That's exactly what I want. And that, I was like, yes, Q, I don't know who you are, but thank you. Use board games to explain math, not the other way around. Okay. Okay, so this is one of my, I know who this person is, and it's just because she was a math major, and she ended up picking up a lot of the stuff and applying it to the game. So at the end, she was unbeatable. She knew that she couldn't have those circles, and she has to connect everything. She was killing it. All right. The notes were organically written, and that's a lie. They're organized. Fun topic and excellent proof practice. Group work, this is another thing that I really like to do. I like to do group work, and the reason is because students like that. Students like trying to thrive a little bit more when they're working groups. The work group emphasis the game base, obviously, because they play games and not have a class, but still a class. Progress is at the speed of the group. I always try to just go along with it. And the last one is this course was amazing, and I should definitely tell again, since it's a topic course, we don't teach it often. And I told these kids, I know who this person is. I was like, oh, well, I don't know if I'm going to teach it again. So her friend could not actually, couldn't take it. So that's why she was saying that. Well, thank you.
Oh, perfect time. Does anybody have any questions for Likin?
So you taught this particular course how many times?
Okay, these are with games too.
With the games?
Without games once.
Okay, so I was just thinking, so if you were to teach it again, what would you tweak? What would you change?
Well, the thing that they said, I think that I do agree that sometimes the game reflections are a little bit repetitive because they play the same game,
Okay.
and then they have to put the same thing. That's a good question. What else would I change? There was one of the suggestions is that in active learning, and in particular in IDL, it's very difficult to contain yourself.